In this short video, we are going to solve an integration problem using the formula for integration by parts. So evaluate the integral e to the negative x sine x dx. Again, the formula for integration by parts is given here. So we need to determine what u of x is and what v prime of x is from the integral. So from our integral is, so we have integral of e to the negative x sine x dx. So this means that e to the negative x sine x is equal to u of x v prime of x. Now it is in this case it's a lot easy because whichever you set to be u between e to the negative x and sine x and the other one v prime of x is going to work. So because it's easy to integrate e to the negative x, and it's also easy to find its derivative, it's easy to integrate sine x, it's also easy to find its derivative. So whichever we choose to be u of x, it's going to work, except the product. We cannot set the product to be v prime of x, nor setting it to be u of x. So let's say u of x in this case is e to the negative x. That means u prime of x is going to be negative e to the negative x. And if setting u of x to be e to the negative x, it means that v prime of x is the other factor, which is sine x. And what is sine x? Is the derivative of negative cosine. So negative cosine x means that this you have v of x. So the integral of e to the negative x sine x dx. Now as u is e to the negative x, and v is negative cosine x, and minus integral of v negative cosine x times the derivative of u negative e to the negative x dx. So this is equal to negative e to the negative x cosine x plus, minus integral of e to the negative x cosine x dx. So what we did for the previous integral, we can do the same thing here to get our the integral of e to the negative x cosine x. So at this point we set u, the new u of x, to be e to the negative x. That means u prime of x is negative e to the negative x, and the new v prime of x is cosine x. That means v of x. What function has derivative cosine? It is sine x. So this said, integral of e to the negative x cosine x is equal, dx is equal to uv. That means e to the negative x sine x minus integral of v sine x negative e to the negative x dx. Okay, so going back to the given integral of e to the negative x sine x is therefore negative e to the negative x cosine x minus, open brackets, e to the negative x sine x minus integral of, now see that we can move the sine x outside, or the negative sign outside, become plus integral of e to the negative x sine x dx. So taking away, removing the brackets, we get negative e to the negative x, negative e to the negative x cosine x minus e to the negative x sine x minus integral of e to the negative x sine x dx. So it's like we kind of went around, right? Or went around sine x dx. So what does this mean? If you were given this equation, x equals a plus b minus x, how will you solve it for x? I'm sure you will move the negative here and get 2x equal a plus b. And that's exactly what we are going to do here, because this quantity, I don't want to include the minus. This integral is exactly the one we have on the left. That means if we move it to, we add that quantity to both sides, we get the same thing. We get twice. So 2 integral of e to the negative x sine x dx is equal to e to the negative e to the negative x cosine x minus e to the negative x sine x. Sounds great, isn't it? So it means that dividing both sides by 2, so if we say divide it by 2, divide all this by 2, then we obtain integral of e to the negative x sine x dx equals negative 1/2 e to the negative x factor 2 cosine x plus sine x. Cosine x plus sine x. Oh, we forgot, let's say plus constant. Don't forget that. And this complete the proof. You can use the rule for trigonometric rule to simplify cosine x plus sine x.